Hello, this is Math 1101, sections 4, 5, 7, and 8. And this is the lecture coming up for Monday, April 19, or Tuesday, April 20, as long as you've taken care of it before the live lecture of Wednesday, Thursday of this week. That would be okay. Sorry for getting out a little bit later. I've been kind of busy with lots of things. Going to a Laker game, going hiking, and et cetera, et cetera. So, so here I am Sunday. This should be out today. And apologize for those of you who maybe wanted to get a little bit of an earlier start. But here we are in the middle of 8.1, measuring voting power. Does my vote count? And we have some examples for you about some definitions. And once again, these really aren't about formulas. They're about practicing the procedures. And you don't have to know how to spell the names, but you should be able to remember the connection between Benjoff and what we do with him and Shapley-Shubik and things like that, which do have names put on them because they were considered groundbreaking at the time. But some of you have already seen this, so some of the sections of this will be a review, and others have not seen it, depending on how fast I was going in each section, which does vary from class to class, although I try to make it the same. Meanwhile, Benjoff Power Index. Let's review for most of you. It's the number of times a voter is critical in some winning coalition divided by the total number of instances in which any voter is critical. So you just round them all up, find all the critical votes, and take, say, Abe, and take how many times Abe was critical divided by the grand total. And do not put it in a decimal. Put it in either a fraction, reduced fraction, or a percentage, rounded any way you'd like. To the nearest percentage, nearest tenth, even nearest hundredth would be fine. Just be sure it's rounded correctly. But then we have the swing voter. This is something that's new to some of you. Suppose the voters vote in order, and we have to take care of all the permutations, all the orderings. The swing voter is the voter whose vote makes the total meet the quota and then decides the outcome. So if you take care of all the orderings, there's no bias. So it doesn't matter which order you put the orderings, the permutations, but as long as you take care of all of them is the important thing. Okay, so although some of you saw this already, think of it as a review. Members of the EU have votes on the Council determined roughly by a country's population, but progressively weighted in favor of smaller countries, kind of like America, weighting it a little towards Wyoming and North Dakota. Suppose that these three countries serve as a committee. So we're only going to look at these three countries, nothing else in the Union. And there's a committee, and a simple majority wins, and the quota is 8. Why? Because 7 plus 4 plus 3 is 14. Half of 14 is 7, and more than 7 is 8. Don't go to half votes. Make a table with all the permutations of voters and then the swing voter in each case. And as we look at all of them, we can see a pattern emerge that actually has to do with the strength of each particular country. And it may or may not be proportional to their number of votes, as we've seen. Some are kind of proportional, some are not even close to proportional. And yes, we would have 3 times 2 times 1 permutations involved in this. And don't worry about the formula. But if you had 4 in this, you would have 4 factorial, which is 4 by 3 by 2 by 1, which happens to be 24. I think we'll look at one of those a little later on. Okay, here is this particular instance. And so they've not put it in alphabetical order, which is what I would have done. I worked in a library for a few years at Cal Poly Pomona. Just think alphabetically a lot of the time. But anyway, if you start with Ireland and you're looking for a quota of 8, so that's what we have to find. 7 is not enough, but 7 plus 4 is 11, and that is enough. Cyprus is the one that swings the vote. We don't have to worry about Malta in this first case. So let's go to the second case. Ireland once again has 7. That's not quite enough. It's half. Then we go to Malta. That's 10. That's enough. Malta is the swing voter. And as you can see coming up now, all the rest are Ireland's, but they're not on the first vote. Nobody has majority right off the top, or otherwise there wouldn't be too much to talk about. But Cyprus, well, yeah, Cyprus doesn't quite do it, but 4 plus 11 is 11. I'm sorry, 4 plus 7 is 11, and 11 is greater than 8. So Ireland, the second voter, once again, is the swing vote. So 4 plus 3 in the fourth case is not enough. 4 plus 3 is 7. 7 is not quite there. You have to go all the way to the end to get all 14, and then you finally get Ireland as your swing voter. In the fifth case, Malta doesn't do it, but 3 plus 7 does, and so Ireland again. This second vote is the swing vote. And in the last and sixth case, you've got 3 plus 4 is 7. That's not enough. You have to go all the way to the end. Once again, Ireland takes over. So you see a lot of Irelands there, and that has a lot to do with measuring the index. Excuse me, sorry. The Shapley-Shubeck index, calculated as the fraction or percentage, not proportion, of all permutations of the voters, in which that voter is the swing. So we compute this power index for these three countries, and there were 6 total cases, and you notice that 4 of them were Ireland. So they have 4 over 6. That's not a good final answer. We should say 2/3 or 66.7%, or however they decided to round it. They rounded it to 2 decimal places. That's fine. What I don't want to see is 66.66% though, because that doesn't show rounding. So please round to the nearest decimal or nearest whole number if you'd rather. Cyprus and Malta only showed up once, so there they are. Cyprus once out of 6, Malta once out of 6. That is almost 17% each. There's a little bit of round-off error on each of these. Do not worry about that, but it essentially adds up to 100%. Anyway, Ireland does dominate the proceedings, even though they only had half of the vote. 7 out of 14. Only 7 out of 14, but it expanded out to become 2/3 of the power, according to Shapley-Shubeck. Okay, let's try another example. Here we have, we've got another example. Maybe I'll get back to that in a minute. In the 2012 presidential election, swing states were especially important in determining the outcome. And although this doesn't directly tie into the example, let's just take a look at these 4 votes from the 4 different states, chosen sort of at random, I guess. Virginia, Wisconsin, Colorado, Iowa. Now, let's assume that somehow these 4 states represent all 51 states in the D.C. They don't, but let's just take them out anyway, and assume a simple majority vote from just these 4 states would determine the election. How many permutations of these 4 states are there? Well, there's a lot. We did mention 24, so let's take a look again. The number of permutations is 4 factorial. That's that notation that we didn't really use very much in this class. If you don't happen to remember it, don't panic. I'm not asking any questions on it. But if we did give you a foursome, you would have to get to 24 on the list. That would be a long list. If I give you a problem like that, I'll be cutting back on other problems. I'm not saying I'm not going to do it, but perhaps it's better, possibly, for me to pick more shorter problems instead of less difficult problems. But we'll just have to see what I've done in the past and see how well it worked. Anyway, 24 possibilities. What is the quota? Well, the quota, you have to add up the numbers. 13 plus 10 plus 9 plus 6. That's 23, and 9 is 32, and 6 is 38. Divide by 2, you get 19. Add 1, you get 20. Yes, they got 20. So, in case you didn't see it immediately, just grind it out. And let's go back to the part number 3. Make the table. Here comes the table, and then find the index. Okay, so here comes the following table showing the different permutations of the 4 states and then the swing vote state in each case. So one way to remember this is Shapley-Shubeck has S's in it, and so does swing. So a memory trick there, if you see all S's, you're talking swing votes, not something else. Okay, this may be a lot to look at, and maybe I will not go through all of it, but let's go through some of it at least and see how we determine the swing votes. So say we have Virginia, Wisconsin, Colorado, Iowa in that order. And they're going to take all 24 of them, as you can see. And we need to get to 20 out of the 38. So the quota is 20. Quota. Okay, 13 doesn't do it. In fact, nobody can get it on the first try, ever. But 13 plus 10 gets it. That's 23 as you add it up from left to right. 23 is more than 20. Wisconsin is the swing vote. And the second try, 13 and 10, exactly the same thing happens. The only thing they did was flip the bottom 2 states. Wisconsin's still ahead on the swing vote here. So looking at the next one, we have Virginia and Colorado. That takes it to 22 when you add them up, 13 plus 9. And when you beat 20 or get to 20, you're good. So Colorado is also the swing vote. And the same thing happens again. Looks like we have lots of pairings. And there's the Colorado again on the fourth try. But then Virginia, Iowa only gets you to 19. Not enough. We have to go all the way to Wisconsin to get to the 29th vote, which finally gets us past the quota. So that's why Wisconsin on the third state is the one. And because these seem to go in pairs, same thing happens again. Virginia, Iowa, not enough. Add in Colorado. That is your swing vote because that gets you to what, 28. So let's look at a couple of these. Wisconsin, Virginia, the two heaviest ones. Of course, that sends you to the second one, Virginia. The best you can do is get it on the second state, going in order each time. And Wisconsin, Virginia, again, gets you to 23. That's a quota. Well, Wisconsin, Colorado is only 19. That's not enough. Barely missed it. But you have to go to Virginia on the third vote. Well, if we put Virginia at the end on this try here, Wisconsin is 10, Colorado's 9. Not enough. That's 19. And you get to Iowa, which is 25. So Iowa finally gets a swing vote. So they're not shut out. Everybody's gotten some kind of say in this. Although it doesn't look like Iowa's going to get too many of them. Then let's see. Wisconsin, Iowa, not enough. And you get to 13. 16 and 13, 29. Virginia, again, takes the lead. Virginia having the most votes. You might figure in most cases they'd get the most swing votes, but sometimes you could be surprised. So Wisconsin, Iowa, not enough. Take Colorado the third try, and Colorado is your swing state there. And, well, oh, it looks like I can't move the screen around. Oh, yeah, so it looks like I have to, that was a little annoying. I actually didn't know that. Do I have an easy-to-find eraser? Let's see. Eraser. I don't see the eraser. There it is. Okay, so let's try the eraser. Tap that. Okay, so I don't know why all that is, but let's just erase all that so I don't have to worry about them being out of alignment. And let's see. Let's try the third group, Colorado, Virginia. Don't know what that. Okay, let's get that out of there. And Colorado, Virginia down here, as I try to get it back, gets us to, well, let's see, turn on the pen. That would give us Virginia. Now, of course, my pen doesn't work. I haven't fully erased it is why. Okay, let's, anyway, I don't care about that. I just wanted to erase. Okay, so that's erased. Now I can get back to drawing. Okay, so here we go. Colorado, Virginia. Virginia is 22. Once again, Virginia is a swing state. Colorado, Virginia, same thing exactly almost, and that's Virginia again. Colorado, Wisconsin, frustratingly close when you get to 20 as the quota. 19's not enough. Virginia takes it again on the third try. Colorado, Wisconsin, nope. Iowa takes it this time to get to 25. So you get the pattern. The idea is to see what pattern is going on here. It isn't me going through every single little step for you. This is the type of thing you should be able to do without taking forever. So pick up a little speed as you go along. Some students want to plod along very, very slowly, and that may be fine on homework to a point. But at some point, you really need to try to pick up a little bit of acceleration, and that's a tough thing to learn. But just be methodical. Try not to be distracted. Just try to calmly think about it and just go a little faster, a little faster. And then on a test, you'll have nothing to fear at all. So just keep going at it. And if you don't happen to finish every single thing, don't panic about that either. It will be a 2-hour test, so the test will be longer when the final comes along. Anyway, let's see if we can figure out the last of this Colorado group, this part at the end here. Colorado, Iowa, not even close, but you get to 13, that's 28. Virginia, again, is the swing. Colorado, Iowa, only 15, but then Wisconsin is the swing. And now I've kind of run out of room. I do have to erase before I turn the page, or it just doesn't stay in alignment. So let's erase that stuff. And I guess I have to erase that, and then we'll scroll. I think I can scroll. Maybe I need to squeeze. Yeah, that's good. Okay, there we go. That's really small. But I was just going to quickly go through this. Iowa, the low state, leads off in all this bottom group down here. And let's see if I can get the thing to work. Okay, so Iowa, Virginia is not enough, but Wisconsin is. And let's see, get back to There we go. So Wisconsin is the swing there. Iowa, Virginia, 19 to 928. Colorado is the swing. Iowa, Wisconsin. You have to go past 2 states every time on this one. And that's only 16. 16 and 13 is 29. Virginia is the winner. 6 and 10 is 16 plus 9. That's 25. That's enough. 6 and 9, 15 and 13, 28. Looks like every time it's the third voter, the third state voting. 6 and 9 at the very bottom is 15 and 10 finally gets you your 25, and that's more than the quota, so that's good news. So now we have all of these to tally up. There's 24 of them. We saw that was 4 factorial, 24, and then we just look at them state by state. Let's take a look at the smallest state, Iowa. Iowa shows up twice. Iowa, IA, I was there once. There's only 2 out of 24. If you want to have a fraction, 1/12 would be a good answer. But that's right around 8%. And then all the other states show up on the next slide. So let's just go ahead and take a look at the next slide. So they go through talking at the first row, and Virginia is not enough to get to 20. So they show you how you have to get to exceed 20 or more. And that was the first line. And they take a look at the 5th row and say have a further explanation on that if you'd like. So you can definitely check that out if you want. And anyway, Shapley-Schubeck has calculated this fraction just like before. It's kind of the same idea, except you don't have more than 1 on the same line. And you don't have none on the same line either. You always have exactly 1 swing vote for every single instance. So 24 separate ones. We already saw Iowa was only 2 out of 24. You could reduce that to 1/12 for full credit if you want to stop at a fraction. Most people, I think, will go to a percentage. And I'm not talking decimal here. I'm talking about a full-on percentage with as few or as many decimals as you like. Well, Wisconsin and Colorado were tied at 6 each. 6 out of 24, also known as 1/4, is 25%. And Virginia got 10 out of 24, 5/12, and that's about 41.7%. And let's just take a look at Virginia. Virginia shows up a lot. Virginia's there. That's 3, 4, 5, 6, 7, 8, 9, and 10. So Virginia does stand out, and they did have 13 votes, so not that surprising. What might be surprising is that, well, the proportion is sort of intact, but not exactly. Before we had 13, 10, 9, and 6. 13, 10, 9, and 6 for the states. Virginia, VA, Wisconsin, WI, Colorado, CO, and Iowa is an IA. So then we can look at their percentages, and Virginia got the most percent, rounded to the nearest percent. I'll just go ahead and do that. That doesn't want to write there. It's supposed to be a percentage. 42% Virginia, 25% Wisconsin, Colorado. Those are pretty close. So this looks fairly proportional, and Iowa only 8%. So that's lining up about what we thought it would be. So there's no huge surprises here. A lot of the time it just kind of works out that way, nothing extraordinary. What is extraordinary is when things completely change, and we do have instances of that. We already saw Kate, with only 3 votes out of 40, having exactly the same power as her neighbors with far more votes. And we can see examples like that coming up. Let's see, before we go to 8.2, though, let me take a look at some other situations. When we go to example 8.4 in the try it yourself, and we go back to Malta and all those other European Union type countries, we could take a look at another similar situation. I think I may have barely enough room here to squeeze it in. Looking at the try it yourself, you can find in your book, Try It Yourself 8.4, Germany, which I'll call G, see if I can just get this here. G has 29. It's supposed to be a G. We also have Spain, I'll call it SP, is 27 votes, and Sweden has only 10. And this one actually fits the mold of Kate, for lack of a better terminology. Sweden doesn't have that many votes, but the top 2 are nearly tied. And when they're nearly tied, that third voter really does have undue power. And let's just see how this would line up. In fact, it's going to look very close to what we just did. Let me see if I can get the eraser going on this part of it just to get it off the screen. Give me a little extra room. Back to the coloring. So as I go and put them in order, and I'll just do it in the order of, just like they did, the order of votes. So not necessarily alphabetical order, although it happens to be alphabetical order by coincidence. So in the first case, Germany has 29. Before we go any further, though, we need to see what the quota would be on this. We have 29, 27 versus 10. So we add all those and we see how many total votes there are. There are, let's see, 6, carry the 1, that's going to be 3, 66. Half of 66, which is the total, is 33. Quota, I'll just say Q for short, is 34. 33 plus 1. So in the first case, Germany has 29. Nobody has a quota by themselves, so the first vote can never be the winner for the swing vote. So if we go to Spain, since we have the top two, we'd better have a quota, and we do. Spain is the winner, and yes, we have Sweden. Sweden doesn't matter. So over here, I'll put down the swing voter, abbreviated as SP for Spain. Okay, and then continuing the same pattern as before, if we have Germany, then we switch Sweden and Spain, then we'd have Germany still with 29. Sweden is only 10, but that's enough for a quota. That's 39. All we need is 34. So that means Sweden is now our swing voter. Let's go to the second highest one like they did before with Cyprus. Let's do Spain next. Let's see if I can get my pen to work again. So Spain has 27. I am writing at an angle, so this is a little bit off. I'm afraid I need to change the angle on this. I can't seem to do it. Then we go to Germany. Let's do Germany. And yes, certainly the top two will get you a quota. It looks like we get that second voter each time, and the one we didn't do is Sweden, but that's okay because we already have our quota on the Germany vote. The third voter, second voter is the quota. So let's lead off with Spain again, and this time switch the back two and do Sweden second and Germany third. So Spain has 27, not enough by themselves. Sweden has, however, we saw 10, and that's enough. Looks like the second voter is controlling it every time. So Sweden is, again, our swing voter. So I have two more to go, and let's go down to the Sweden leading off, which of course doesn't come close to becoming the swing voter. So if we do Sweden first, and let's say Germany next with 29, that's 39 total votes going from left to right. That beats your 34. Germany's a swing voter. And the last permutation we have, and let's not forget to put down Spain, even though it doesn't matter. The third vote is pretty much history. Sweden can lead off with 10 again for the last time, and then let's do Spain next. Spain has 27. I barely see that there, but 10 and 27 is 37. That's enough. And even though we did have Germany at the end, we already got Spain to be our swing vote. And now we have our total. There are 6 of them. 3 factorial is 6. 3 times 2 times 1. Spain shows up twice. Germany only shows up twice, surprisingly, even though it has more votes. And Sweden, even though they only had 10 votes, they show up twice as well. Each one of them have a 2 out of 6 or 1/3. So I'll just say each. It's a 3-way tie, 33%. 33 and a third percent, 33.3% is all good. And yeah, this is one of those just like Kate, where that third place person is basically breaking a near tie amongst the top two that do not have a majority by themselves. We're not interested in giving you one that flat out already has a majority because there's not very much to do there. They exist. We're just not interested in them because there's nothing to do. So there's another example, and certainly there's written homework that I will send along to you before too long that you can practice to get the idea. And certainly now that you have this available in the cloud, you can, or online on YouTube, you can do it on your own and then double check to see what I did and then verify that you got it correct or not. Plus I think you can also find it in the book as well. Okay, let's move along and see what we have here. We've got the states, that was 8.6. And yes, we did 2 examples at once, and that we also calculated the Shapley-Shubik index for those 3 countries with different voting patterns than the other ones from the European Union. I think we're getting close to 8.2, so let's see how far we can get in 8.2 before we basically run out of time. I don't go for 75 minutes on these recordings, hardly ever. I try to go somewhat less, up to about an hour or so, because I figure you're stopping and starting and rewinding and all that kind of stuff. So we don't need to go that fast anyway. As we go to section 8.2, this is voting systems. How do we choose a winner? Well, there's all kinds of ways of choosing winners in these things, and this is a longer section, so I'll spend more time on it. So we have this thing called a voting system, a set of rules under which a winner in an election is determined. And plurality voting does not need a majority. This is a system in which the candidate that receives more votes than any other candidate is the winner. And in some cases, it may not be a majority, but that the rules have to be defined in advance. It just depends on how it's been defined. So if we have it defined that way, that's all we need. So not necessarily a majority. That may be a majority, but it doesn't have to be. So not necessarily, I'll abbreviate that. And so here's a very brief example, but it's important, of 4 candidates and 100 votes, which is the smallest number of votes needed to win. Okay. Well, here's how we could do it. If you had a 4-way tie, it's possible. If the 4 candidates had an equal number of votes, they would have 100 divided by 4, 25 each. Then all you would need is to move the needle by 1. To take your 1/4, add 1 to the winning candidate. I mean, somebody else would probably have 24, but who cares? A candidate, the winning candidate, could have a plurality, not a majority, as few as 26 votes. That doesn't seem like much. Here's another example that they do as well if you were to take 5 candidates. So this is also found in the book, and try it yourself. So if we had, instead of 4 candidates, 5 candidates, I can squeeze this in with it being readable. Same question. So let's take a look at that. And to follow the same lead here, you could take a 5-way tie. That's the way I look at it, 5-way tie, which doesn't seem likely, but let's assume that it could easily happen. And if it were that way, it'd be 20 votes apiece. No abstentions, no 6th party candidate, so it'd be 20. So all you have to do is add 1, or somebody move the needle, just 1 vote. And if you add 1, sorry, I'm jumping ahead, you get to 21. So that means the results would be 21, 20, 20, 20, and then somebody would have to have 19 because they would have lost their vote to the winning candidate. So 21% doesn't sound like a winner, but it's happened before in plurality systems. Now, when states or counties do not like this, then they go to majorities, and that seems to be very popular, majorities, but there are pluralities out there. Okay, we have this definition called a spoiler, a candidate who has no realistic chance of winning, but whose presence in the election affects the outcome. There have been several 3- and 4-way battles in history. When Lincoln first got elected, there was a major 4-way battle, and there have been other 4-way battles as far as presidential candidates are concerned. There haven't always just been 2 parties. There have been other situations where there were many more than 2, which I think is healthier personally, but that's just me. Anyway, back in 1996, some of you might remember this. I know I do. In the 1996 presidential race, there were 3 major candidates: Bill Clinton, Robert Dole, and Ross Perot. And for Florida, which seems to be in the news quite a lot because it's rather balanced as far as the parties are concerned, let's just take a look how close it was in Florida back then, a few years back. So as you see, Clinton got about 2.5 million votes. I'll just round these as we talk. Dole got about 2.2 million votes. Perot was the 3rd party candidate, got about 500,000 votes. And yes, we do talk about the others, around 30,000 or so. And 5.3 million votes were cast. Okay, so now what? What percentage of all votes cast in Florida were for Clinton? And did any candidate get a majority of votes? Let's take a look. All you have to do is look at the total number of votes, about 5.3 million, use your calculator. Clinton got about 2.5 million votes. And when you divide those 7-digit numbers by each other. Clinton only got 48% of the vote. This is not a majority. As you know, a majority is 50% plus just a little more. Can't be exactly half, it has to be more than half. Clinton won more votes, but no candidate got a majority. He would have gotten a plurality. They're not being too clear as to whether plurality did it or not. I think he did win on plurality here, but that's not the main point right now. Let's go to problem number 2. Okay, here it is. Florida did determine the winner by plurality. So Clinton did win all 25 votes, even though he did not even get a majority. This has happened before. Abraham Lincoln had that happen when he won 39% of the popular vote and won president. And of course, there was a civil war right afterwards. So anyway, check your history books for the details. Let's suppose the vote was conducted with only the top 3 candidates. Well, okay. All their supporters continued to vote for them. Would it be possible for any of the 3 to achieve a majority? And this is a big if all the votes cast for others were awarded to Clinton. Okay, this is just a hypothesis. It's not realistic probably, but let's just see what would have happened. So I zoom ahead to the answer. Notice the others weren't very large, so I don't think that has a tremendous effect. But would that put them over the line? Would it make it 50%? Let's just see how close it was. So we put in the 29,000 other votes to Clinton. Then he would have received a little bit more like 2.6 million votes. But still, half of this number of votes is 2.65 million votes, rather. And so that's not enough. Not enough. He still wouldn't have a majority. He has around, 49%? That's still not quite a majority, but it turns out in Florida it didn't matter. So certainly the same is true of the other candidates. If Clinton was the leader and he can't make it over to the majority, then of course neither one of the others can. Even though Dole was pretty close, Perot would not be able to be close to a majority here. What about number 3? It was speculated that by far most Perot voters would have voted for Dole if Perot was not in the race. So sometimes that happens. In 2000, there were actually 4 candidates, and you had left, right, and far left, far right, I guess you could say, to be simplistic about it. And so those on the left would tend to vote for the left candidate. Those on the right would tend to vote for the right candidate if their main candidate wasn't available somehow. And this is kind of what happened here. I guess Perot was sort of on the right, and so was Dole sort of on the right. And so they said that most of them would go for Dole if Perot had dropped out. And he continued running, 92 and 96, I guess it was. Anyway, suppose that 83%, that's 5 out of 6, of Perot voters would have voted for Dole. So give most of the Perot voters to Dole and see what happens. And just a few to Clinton, about 1 out of 6 for Clinton. So, okay, 17% for Clinton. How many votes would Clinton have had? How many would Dole have had? So this would have evened the race a little bit. And then who would have won the election? And then would you call Perot a spoiler? So let's take a look at this longer question 3. Okay, so given this hypothesis that 83% of Perot's votes go to Dole, then Dole would have received 83% of Perot's nearly 500,000 votes, or an extra 402,000 votes. And then he would have gotten to 2.6 million. But Clinton would only carve up a little bit of this pie out of the 500,000. He'd only get an extra 82,000. So there'd be a few people that would say, oh, I don't care for Dole, I'll go over to Clinton. Not as many, but there'd be some that would. But then notice how he is at 2.629 million, and Dole is suddenly up to 2.646 million, and Dole would have won with a margin of 17,000 votes. Slim, but Florida also had a very slim election of around 500 votes when Bush beat Gore by about 500 votes. So it's been done before. You could look at other historical cases where there have been very, very slim leads. So this is a what-if hypothesis, though. So, yeah, if this were indeed true, if most 83% of Perot voters had swung over to Dole because Perot dropped out, then Perot would have been a spoiler. So Dole would have won. Dole actually would have won under this scenario. Say if all the votes from Perot went to Dole, it's even stronger. So Dole would have been the winner here, and Perot would have been called an official spoiler. And that's what happens when a spoiler would win. He didn't really have much chance to win. Now, of course, his campaign thought they did. But just look at the definition of spoiler. Candidate has no realistic chance of winning, but how do you define that? Sometimes it's a bit ambiguous. But his presence in the election affects the outcome. So in this case, he apparently would have affected the outcome. But of course, you're making an assumption that so many of the votes will go to Dole. And that probably is the case, but nobody knows for sure. Nobody would ever know for sure. You could try exit polling or something like that and get an approximation. Okay, let's shift gears here and go to preferential voting systems and see what that's all about. We have, so I take a look at some of my notes here. Systems in which voters express their ranked preferences between various candidates, usually with a ranked ballot, which is used to avoid several rounds of voting. Remember when I talked about the 100 ballots that were taken in a convention? I don't remember what party it was, but it was somewhere in the early 1900s in the heat and in the non-air conditioned buildings, and it took 2 weeks to finish a party convention that normally takes 4 days. It took 2 weeks. And so if they want to avoid that kind of thing, which they did a pretty good job of avoiding, because now they don't even really vote realistically, they just have infomercials, as I complained about earlier. The ranked voting would tend to minimize this kind of discrepancy, because then your second place vote actually does matter a lot, more than you might think. So if you have to rank your top 3 or top 5 or whatever, that does actually have an effect. And we'll see how this works here. So here's 2 examples that follow. There's the top 2 runoff system. If no candidate gets a majority, then there's a new election with only the 2 highest vote getters. This is only realistic when you have 3 or more candidates. Let me see if I can get this pen to work again. Okay, there we go. See if you had more than 3. If you only have 2 candidates, neither one of these matters very much. So we'll look at that one first, the top 2 runoff system, and then later we'll look at the elimination runoff system. If no candidate gets a majority this time, the lowest vote getter is eliminated, and a vote is taken again amongst who are left. And this repeats until majority is reached. This one takes the longest, because if you have like 5 candidates and you're only eliminating them one at a time, it's kind of like Survivor when someone gets voted off the island. Eventually they do get to a winner, but it may take a while. So top 2 speeds it up just a little. Let's take a look at this one. And this will be the elimination method. So they're actually leading off with that one. Okay, that's fine. And let's take a look at that. Looks like we're not doing top 2 right now. Okay, so consider the following ranked ballot outcome for 10 voters choosing amongst 3 candidates, Alfred, Betty, and Gabby. So they vote in groups for some reason. Maybe it's a coincidence, but it's just for the textbook anyway. But 4 voters go for Alfred as their first choice, Betty as their second choice, and Gabby as their third choice. And these 4 voters go Gabby first, Alfred second, Betty third. And only 2 voters put Betty first, and then Gabby, then Alfred. So they're all kind of staggered, but the 4-4-2 does split it off some. So under this elimination runoff system, which we're doing first, let's see what the winner might be. So what the idea here is to see that no candidate has a first choice majority. Let's go back and take a look at this. If you only look at the first choice, Alfred has 4, Gabby has 4. That's a tie. Betty doesn't count. So Alfred and Gabby are tied. So Betty has the least. She is eliminated from the first round. And with only 3 candidates, it's not going to matter so much. If you had 5, it would take quite a bit longer. I think the book has an example closer to that. So Betty's gone. She's out of there, whether she was first, second, or third. And then we just compress the 2 after that. And in the 4 voters in the first column, Alfred is still first, and Gabby moves up to second because Betty's gone. In the next one, it's kind of a moot point. The second column has Gabby first, Alfred second. Okay, that hardly really changed. But look at the third column. Betty was the winner there, but she's gone. That means Gabby takes the lead, and that's quite important. So that's what's going to turn the tide for her. Or I believe that's a lady. I'm not quite sure. Anyway, first choice votes now are only 4 for Alfred, like it started off, and Gabby got her 4 over there, and then 2 more that got as a surprise when Betty left. And now 6 goes to Gabby, and Gabby has a majority and is the winner. Let's go over to what's called the board account. Our first choice loses. That's an interesting way to put it. And they have this item talking about, let's see, yeah, we'll save that one for later. Yeah, we'll do that later. So anyway, what they want to do is there's 5 people. They need to make a decision as to what food to order. And to make a choice, everybody marks a ranked ballot for pizza, burgers, and tacos. Apparently, they're all kind of in groups. You can't just buy individual orders here. It's like a party pack or something. So you got pizza, tacos, or burgers. And so 5 people all kind of vote for their first, second, and third choice. And what happens is 0 points go to your last place choice, and 1 point goes to the next higher, and then 2 goes to your favorite choice. So number 1 gets 2 points, number 2 gets 1 point, and number 3 gets 0. So that's the number of points. I'll say PTS for points. And so they have 3 people that all voted the same way. They're listing them separately, though. They like pizza as their first choice, 2 points each. And then tacos were their second choice, 1 point each. And neither one of these 3 people like burgers that much. That's their third choice. And then we have 2 other people that vote in a different way. They didn't like pizza at all, so it's kind of balancing that out a little bit. But they liked tacos more, so they gave that the 2 points. And then burgers were their second choice. And did one of the foods receive a majority of first choice? Let's take a look. First place votes are indicated by the number of 2, and there were 3 first place votes for pizza. And that's a majority of the 5 first place votes. Let's take another look. Yes, 3 all were number 1, and that is a majority. Yes, 3 out of 5 picked pizza. So it seems like we should all get pizza, right? Maybe, maybe not. Now, here comes the board account. You add up the points. That's it. You simply add up the points. So, for example, pizza, 2 plus 2 plus 2 plus 0 plus 0 is 6. But look at what happened to tacos. And looking back here, you had all these second place votes, 3 of them. 1 plus 1 plus 1 is 3. And then a couple of first place votes. That's enough. Notice pizza didn't get any backup. Tacos did. And that's why tacos wins. So you add up the points, you get 7. And let's not even think about burgers. They didn't do well at all, only 2 points. So according to the board account, another person that got his name on a mathematical principle, the group should order tacos. This is true despite pizza receiving a majority, because at least you got everybody as at least their second choice got in. And that's good. So everybody at least eat them, and 2 of them will even enjoy them a lot. The others will say, wish I had pizza. But not many people cared for burgers that much. And so this lends to our understanding, or we can read more in the book on that, to our understanding that no voting system is perfect when you have 3 or more candidates. When you only have 2 candidates, it's pretty simple. Majority rules, unless it's a tie, and then you either flip a coin or do something else. But when you have 3 or more, it becomes complicated, and you can say no voting system is perfect because different methods can yield different results. So then the idea is going in, you have to have some sort of consensus as to which will be the deciding factor. You can't just say, oh, I want to do the board account and suddenly I want to do a different count. That would not be quite right. That would not be leading to a lot of understanding amongst people. Okay, let's take a look at another example here. And you can find the more up-to-date 2016 Heisman Trophy in the book. This one, however, is the 2013 Heisman Trophy, so in case you follow this kind of thing, and a lot of people do, college football, you can see how the first, second, and third place votes were concerned. Now, there may be more votes than this. I'm not quite sure. I know Baseball Hall of Fame has several more votes besides this, but let's just take a look at this one. And as before, the last place vote gets 0. So you start with that. So in case there's a fourth place vote, they would actually get 0 points too. So if I can get the pen to work, it's always an issue. So 0 points for the third place votes. You get 1 point for second place vote, but you get 2 votes, 2 points, that is, for first place votes. So looks like Jameis Wilson is going to run away with it because 668 first place votes, that's going to be pretty hard to beat. So this is going to be like the tacos and pizza example, I don't believe. And you have several other people with not nearly as many first place votes, but they do have more second place votes and certainly more third place votes. So let's take a look at the board accounts as we multiply them out. So Winston has 668 first place votes, which is doubled. And then you get 1 point for the second place votes also. And then basically these are kind of basically zeroed out. But probably shouldn't do that, but those will not count towards the board account. And, I've seen some students on tests or finals go ahead and do a 3-2-1 situation. That's not terrible because it still keeps exactly the same winner, but I'm afraid that's not full credit either. So keep in mind, the first place vote gets 2, second place vote gets 1, third place vote gets 0. If you happen to do a 3-2-1 setup, you will get the correct answer, but the work will be slightly screwed up. So that might be like 8 out of 10 points, something like that. I'd have to ding you a little bit, even though you still got the idea. And the same would go for a 4-3-2 setup. If anybody ever thought of a 4-3-2, which I don't think anybody would, you'd still get the same structure. It would still give you the same answer, but you should try to minimize it. Plus, anytime you could throw a 0 in, that just helps your deal. It definitely helps. So the 0 will definitely make your life easier because notice all these calculations barely even need to be there. You write them down for sure, but they're not going to count towards the points. It's just the first and second place votes that matter here. So you got McCarran. Okay, by the way, Winston did get 1,420 total points on the board account. McCarran, 79 first place votes and 162 second place votes, 320. Looks like he came in second overall. Lynch, 40 times 2, 149 times 1, 229 votes overall. Williams, not so many first place votes, got the least of them, and a lot of second place votes. Yeah, third place votes are there, but they're all zeroed out, unfortunately, so it looks like he came in fourth. Manziel got 30 first place votes, 103 second place votes, even 125 third place votes. 163 is good enough for fifth. So Winston is the winner. This one did not seem to be all that close. And if you care to look at the book, I don't have that available. Lamar Jackson in 2016. In a slightly closer situation, although not much closer, somewhat closer. Lamar Jackson was the winner. Deshaun Watson was second. Baker Mayfield, who I've seen in commercials, came in third. And maybe the others have done commercials too. I just haven't noticed. But they have a Try It Yourself. I'll probably run through some of those later on and get you a little bit more. But this does seem to be pretty straightforward. Just rank them in order. They correctly said start with the last place. If you're going for like 3 categories, just call it last. 0 for last, 1 point for next to last, 2 points for the next highest. So you could, if you had 4 of them, you could have a 0, 1, 2, 3 situation. So the number 1 category would be 3 points, not 2 points. That's not carved in stone. It just depends on how many you're allowing into the board account. And perhaps in baseball, they go for the top 10 or so. That would be even more complicated. And number 4 here would be 0. If you had like 10, then your number 1 vote would get 9 points, and number 2 would get 8 points, and number 3 would get 7 points, all the way down to number 9 would be 1 point, number 10 would be 0 points. So that would be rather complicated. No, I do not plan to do anything close to that. Don't panic. But just to show you. And then sometimes they have weighting too. Maybe they'll give 15 points to number 1 and then 9 to number 2, things like that. I know they've done that with record sales and record charts. They don't always go just by points. They will heavily weight the top ones because they know historically that the number 1 sales is typically way ahead of number 2, although not always. And so they just sort of take care of it that way. I was actually part of that working for a radio station several years ago. Okay, it looks like that's about it for today. We'll continue in the middle of 8.2 and we'll review some more of these things, the board account. Looks like we didn't actually supply you a top 2 runoff system. That was kind of combined under the elimination runoff system because the 3 turned into a top 2. And eventually, when you talk about the elimination runoff system, it becomes a top 2 kind of by default. So perhaps that's why they chose not to really emphasize it by itself. Because that's just the outcome of the elimination system. So that's got to be their way of thinking on that one. Okay, we'll see you live again on Wednesday and Thursday of this week. And study hard, and we'll talk to you soon. Bye-bye.